spike proteins and Nisstex. In this video, we'll get to know about some aspects of the spike proteins, what are they, and how do we handle them, and what do they do to our body as well. Okay, what is spike protein? Actually, spike proteins, um, they are a key part of the coronavirus. Okay, it belongs to the coronavirus. If you have seen picture of the virus, you probably notice that there are little spikes sticking out of its surface. These are the spike proteins. They are tiny tools that is important to the virus, where the virus uses it to get into our cells. Without the spike protein, the virus cannot enter our cells. Okay, so this is very important. We can think of the spike proteins like a key, and our cells are like a locked doors. Okay, our cells are protected by the lock, and the virus is outside the cell. On the surface of some of our cells, especially the lungs, the heart, there are special locks, okay, called the ACE2 receptors. These ACE2 receptors will be the key factor that can that can allow the virus to go into our cells. The spike protein fits into this lock actually. The spike protein fits into the ACE2 receptor. So the spike protein actually is the key for the virus to go into our cell. Once it connects, when the spike protein connects to the ACE2 receptor, the virus can open the door. Once it happens, it will fuse with the cell and slips its genetic materials into the cell. Okay, so this is very important. Okay, that's how the infection begins. The moment this virus can put their genetic materials and their contents into our cell, that's where the problem will start. Okay, the virus will take over the cell and starts making copies of itself. Okay, so this is how virus can replicate the moment it goes into the cell. So in short, the spike protein is what helps the virus break in and start spreading. Okay, this allows the virus to enter the cells and begin replicating, which is the first step in infection. Okay, this is how it starts. Then let's look at how our body reacts to the spike protein. Okay, how our body receive the spike protein. When the virus enters the body, the immune system quickly notices something isn't right. Okay, it's just like some intruder coming into our house. So we notice, oh, this is not our family member. So it seems the spike protein, um, is seen as a foreigner or invader. Okay, something that doesn't belong to the cell. To fight back, the body activates its defense system. It starts making special proteins called antibodies. Okay, our body is very clever. The moment they see some intruders or whatever, they start getting a reaction to protect the cell from the intruder. Okay, these antibodies are like tiny soldiers that recognize and stick to the spike protein, helping to block the virus from entering more cells. So the antibodies are the one that are our soldiers. Okay. At the same time, another part of the immune system called the T cells gets involved. Okay, these cells they search for and destroy any cells that have already been infected by the virus. So this is our doctors in the cell. Okay, when they see something already infected, they will try and do something. Together, antibodies and the T cells help stop the virus from spreading and protects the body from getting sick. So this is how our body responds. Okay, the immune system. Okay, so this is a summary how the virus entry and the replication takes place. Once the spike protein binds to the ACE2 receptors, the genetic material and the virus can go into the cell and take over the cell. They control the cell, and once they control the cell, they will produce a lot of toxic things. They cause a lot of toxic activity in the cell. The body has to produce antibodies, and then the immune system has to kill the infected cells. So many things happen in the body once the virus enters the cell. While the spike protein helps the virus enter our cells, it can also cause problem. Okay, first, it can damage the cells that line our blood vessels. Okay, this is the endothelial cells. They can damage the endothelial cells. This can lead to inflammation. Okay, we can get a very severe inflammation, and we can get blood clots as well. Okay, we can get blood clots, and um, this causes problem with the cardiovascular system. Okay, you can get inflammation and blood clot in the arteries, or the whatever the pipings in our cardiovascular system. It can happen anywhere, and this will have problem with the blood flow, which can affect the heart and also many other organs. So this is something that we don't want. Okay, the moment when we are infected by the coronavirus, the endothelial will be affected, and we have inflammation, and we have other um, problem with organs. They can have inflammation on the organs itself. Okay. Second, the spike protein might overstimulate the immune system. Okay, just now we know that it also attacks the immune system. So this can cause overstimulation of the immune system. Sometimes the body reacts too strongly, releasing a flood of chemicals called cytokines. The body is not acting normally. It can also make mistake at certain time, and in this case, the body release a lot of cytokines. This can cause what is known as the cytokine storm, which may harm the healthy tissues. Okay, this is what can happen if we have too much of this spike protein, and if they go haywire, it can affect our immune system and cause cytokine storm. Thirdly, in some people, bits of the spike protein have been found in the blood um, long after the infection or even after vaccination. Okay, you find bits and pieces of the spike protein in the blood. This is especially seen in people with long-lasting symptoms, like people getting long COVID. Finally, because the spike proteins targets the ACE2 receptors, which are found in many parts of the body like the lungs, the heart, the brain, and the kidneys, it can affect multiple organs, not just one organ. So you see that the spike protein is quite harmful. Okay, while the spike protein is key to how the virus works, it can also play a role on why some people get very sick, because the spike protein itself is toxic. So it can damage a lot of tissues. It can cause a lot of inflammation. It can attack the endothelial system. So these are not safe for whoever who has high concentration of spike proteins. Okay, now let's break down how an mRNA vaccine works. Okay, that is the the vaccine that is responsible to produce the spike protein in our body. Step one is the injection. Okay, the vaccine is given as a shot in your upper arm. Inside the vaccine is something called messenger RNA, which is like a set of instructions. Okay, these are like a recipe. So it's wrapped in tiny fat bubbles called lipid nanoparticles to protect it and help it to get into your cells. Okay, so the the site of injection usually is a place where we find a lot of the mRNA residing there. Then the mRNA are supposed to enter the cells. After the shot, the mRNA travels into healthy muscle cells. It doesn't stay long, just enough time to deliver its message. Okay? Then the spike protein production stage. Once inside the cell, the cell will read the mRNA like a recipe and starts making the spike protein. That means the spike protein is being made inside your cell. Okay, the same protein found on the surface of the COVID-19 virus. Okay, but this is just protein. It's not the whole virus. They don't produce the whole virus, but they produce the protein, the spike proteins alone. Okay. Now let's look at the immune system response. Your immune system sees the spike protein and says, "Hey, this doesn't belong to here. Okay, these are foreigners. Okay, or they are intruders." Then it starts building a defense by making antibodies to recognize and block the spike protein. Okay, the immune system starts to recognize and also try to block the spike protein in many ways. It activates the T cells, which are like the bodyguards that destroy the infected cells if the real virus ever shows up. Okay, so the vaccine trains your body to fight COVID-19 safely and effectively without needing um, to get sick first. So that is the intention of the vaccine. It's supposed to help. Okay, that is the concept of the vaccine. Okay, but in the mRNA vaccine, it is also since it produces the spike protein, and the spike protein can be itself toxic or dangerous. Okay, even the particles of the spike protein are known to be toxic, and it can cause a lot of damage to the body. After the COVID-19 pandemic, a wide range of diseases and health problems were observed to increase or emerge more prominently. Okay, we see a lot of new problems, new health problems that emerge after the COVID. These include both direct consequences of the virus and indirect effects due to the disruptions in healthcare, lifestyle changes and stress, and also due to the uh, a relatively high amount of the spike proteins in the bodies. And there are many explanations and many findings that relates it to the uh, spike proteins that is present in our body. Some of these are neurological and cognitive issues. People can have brain fog or memory concentration problem. They have headache. They have sleep disturbances, dizziness. They have stroke. These are very common, linked to clotting issues. We mentioned just now that spike protein can cause problems in the endothelial system, and myalgic encephalomyelitis, chronic fatigue syndrome, and these are all that was seen now or since after the COVID pandemic. You have on the cardiovascular system, you have heart disease, myocarditis, and pericarditis are the common ones, and these are inflammation. It causes inflammation of the heart muscles. Okay, and the irregular heartbeat, blood clots, and microclots. These are the most common, in fact, seen through research, where they see blood clots and microclots in the people with high spike proteins. Postural orthostatic tachycardia syndrome. And on the respiratory conditions, you have chronic lung disease, you have shortness of breath, persistent cough, worsening of COPD and asthma. So all these are happening after the COVID um, pandemic. And on the autoimmune and inflammatory disorders, you have got autoimmune disease, which is triggered suddenly and worsen the immune system, the mast cell activation syndrome, persistent inflammation. So all these are happening after the COVID. And you have metabolic and endocrine disorders like diabetes, hyperlipidemia, and obesity. You have general and systemic symptoms like extreme fatigue. For no reason, you become fatigued, you become tired, and you don't have enough energy. You have digestive issues, you have muscle and joint pains, fibromyalgia like symptoms affecting the muscles. So All these are happening, and there are more to that. Mental health changes also begin to appear nowadays. Anxiety and depression increases, mood disorders, PTSD and trauma related symptoms, and exacerbation of pre-existing conditions. Like if you already have a problem, the problem becomes exaggerated or becomes more clear and becomes more significant after that. Chronic kidney disease, cancer progression. This is also very important. Nowadays, you see somebody will get cancer just from nowhere and for no reason, or sometimes straight away stage 4 cancer were diagnosed. And these are all things that is happening. Okay, very difficult to explain, but it is there. The main contributors to the wide range of health problems observed after the COVID-19 pandemic are complex and multifactorial. A lot of people relate this to so many different things, and a lot of findings also relate it to a lot of possibilities. But basically, spike proteins are one of them. Okay, they are one of them that we can relate to all these problems. How do we stop this adverse effect? We already got spike protein because we are already getting we had already got COVID one time, or sometime we get the vaccines. So how do we stop this adverse effect? Okay, many attempts were made to stop the side effects of spike proteins and vaccination. We see a lot of people trying to help, try to create ways to stop vaccination. One of the common one is detoxificating the heavy metals. Okay, you detox the heavy metals because they believe that vaccine comes with heavy metals. Okay, but most of the side effects that were seen on the post-COVID problems, they are not really due to heavy metals. We cannot single out. So it's not necessarily due to heavy metals. Okay, heavy metals cause different problems. Okay, some people detox the liver. Okay, but the problem is that you detox the liver, but the spike proteins are not in the liver. Okay, so there is not much that can help. Okay, cupping, taking away the blood through certain traditional systems. Cupping is very good to remove some toxins and waste material, but um, spike proteins are not usually in the blood. Okay, we cannot remove all the blood clotting problem by cupping. It doesn't work that way. Eliminating toxic chemicals in the blood using various herbs and medicinal preparations are widely available. But spike proteins will not be affected significantly or even clearly by these methods. You cannot explain how it does, and it may not be successful. Okay, the spike proteins are still there. Okay, so what can help us and how? Okay, we need to find a way, and there must be a way. Okay, so this is very important for us to understand. The answer is thymoquinone, which is found in the product Nisstex. Okay, why thymoquinone? Okay, what is thymoquinone? Thymoquinone is a compound that is found in the black seed. Okay, the properties of thymoquinone is quite similar to ivermectin, and they does a lot of things to the body. The power of thymoquinone. See, the thymoquinone can bind to the ACE2 receptors. Just now we know that the ACE2 receptors is the key um, to the entry of the virus into the cell. So if the thymoquinone binds to the ACE2 receptor, the key already goes into the lock. Thymoquinone goes into the lock. So no other key can go in. So that is basically how it does. And studies have been conducted, a lot of receptor binding studies using um, computerization and also using computational chemistry. Um, these are done to find out what is suitable to bind to the ACE2 receptors, and they found out that thymoquinone is one of the chemical that can bind to the ACE2 receptor and prevent the binding of the spike protein into the ACE2 receptor. So this is an indirect inhibition of spike protein function. Another study suggested that compounds in Nigella sativa, including thymoquinone, may bind to the host cell receptors like HSPAS, which are also involved in spike protein recognition. Okay, they could hinder the spike protein's ability to attack the cells. Okay, so these are very important findings. And broad spectrum antiviral potential, thymoquinone has been shown to inhibit pseudoviruses carrying spike proteins from SARS-CoV-2, SARS-CoV, and also many other bacteria. And there's a broad um, antiviral activity. That means thymoquinone has antiviral activity. Okay, it binds to ACE2 receptor, not directly to the spike proteins. Okay, so it may block the spike protein ACE2 receptor interaction. Okay, reducing the viral entry into the cells. It may also affect other host receptors involved in viral attachment. Some of this can help to explain why thymoquinone is a good anti-cancer compound as well. Okay, the spike protein binds to the ACE2 receptors and directs the immune system to be prepared. Okay, so this is a way, and we can see here how thymoquinone blocks this binding of the spike protein to the ACE2 receptors, and this will block the effect of the virus, the effect of spike proteins and all that. So this is very important step to protect our body from the effect of the spike proteins. Okay, so this is the comparison when you have thymoquinone and when you don't have thymoquinone. There are two different effects that can be seen. So we know that the effect of spike protein is very serious. It can affect a lot of things. It can exert a lot of effects on the body. Okay, it affects the immune system, and it activates a lot of things in the inflammatory process, causing inflammation, and also causing damage to the endothelial system, and causing blood clot and all that. Okay, so all these are undesirable effects of the spike protein. The cellular impact, okay, impact on the cells due to spike protein are inflammation. They can cause inflammation. When the body is inflamed, there are a lot of side effects, a lot of problems to the body, okay, which we don't want. Microclot formation, it helps to form microclot because of the damage to the endothelial system. It put up stress on the mitochondrial system, giving you less energy. That's why you have fatigue all the time. You cannot have a active life. And also some of the long COVID symptoms. If thymoquinone blocks this interaction, it will help to protect the cells, to reduce inflammation, and to support recovery. Okay, this is extremely important. Spike protein can cause lung damage without the virus. Okay, this is where the spike protein is active even if there is no virus. The spike protein is not desirable in large quantities in the body. Okay, a study using genetically modified mice showed that injecting only the spike protein without the virus can lead to severe lung inflammation, can affect the white blood cell infiltration, can cause the cytokine storm-like responses. That means this a very strong effect that is not safe to the body. This suggests that the spike protein itself can trigger immune reactions and tissue damage, even in the absence of viral replication. This is how the COVID mRNA vaccines work. When the vaccine is injected, it goes into the muscle cell And from the muscle cell, the mRNA will go into the cells, and inside the cells, they will help to produce spike proteins. And these are the spike proteins that we find in our blood when we have got injection of mRNA vaccines. Mechanisms of harm is due to the spike protein. The spike protein binds to receptors like the ACE2 and possibly the HSPAS, activating pathways that can disrupt the endothelial function, the function of the cardiovascular systems, the blood veins, arteries, and the the lining that carries the blood. Okay, the pipes that carries the blood. These are called cardiovascular systems. That means these capillaries or the arteries or the blood vessels, they can usually they can expand, they can contract, and there is a space inside the blood vessels. And if there is inflammation, the space becomes smaller and the less blood is able to flow. And sometimes there is a defect, they damage the blood vessels. So all these are the problems that can uh, be created by the spike protein. It promotes clot formation. Okay, this is also very commonly seen lately. There is blood clot from nowhere, especially if it happens in the head, it becomes a stroke, and it triggers inflammation for no reason and cause mitochondrial stress. So this the mitochondrial stress makes you feel very weak, very sick, and no energy, and a lot of fatigue problems. Okay, persistence and immune dysregulation. Okay, in some individuals, fragments of spike protein have been found to persist in the bloodstream for months after injection or vaccination. Okay, this may contribute to the immune dysregulation and chronic symptoms seen in long COVID and post vaccination syndrome. Okay, in summary, the spike protein can be biologically active and harmful on its own. It does not replicate or spread like the full virus, but its harmful effects depend on the dose, exposure route, and individual susceptibility. Okay, it's different between individual to individual. So, what is the solution? To reduce the effect of spike protein, thymoquinone can be used. Thymoquinone is found in high concentration in Nisstex. Okay, so taking Nisstex will provide you with thymoquinone, and this will help to block the ACE2 receptors and many other mechanisms as well. It also prevent inflammation and many other effects that you've seen due to presence of spike proteins. To prevent the effect of the coronavirus, okay, if during COVID, if you have the coronavirus, you take thymoquinone or you take Nisstex. Nisstex will prevent the the uh, infection to proceed into more serious disease. Okay, the infection will be addressed or will be minimized or will not give you very serious problem because the thymoquinone will block the ACE2 receptor, and the spike protein will not be able to exert its effect effectively. Thank you very much for your kind attention to the video. Hope to see you again in other videos. Thank you.